In the last two segments, we made some general distinctions between filters and strainers. Filters, we said, usually have disposable paper or cloth depth mediums. Strainer screens are usually metallic surface mediums which can be cleaned and reused. Now, you may remember that we also said there are exceptions to this rule. And in this segment, we'll see some of those exceptions as we discuss three special application filters: knife edge filters, backwash filters, and pre-coat filters. Now, this is a typical knife edge filter. One of its characteristic features is this handle. Shortly, we'll see what its purpose is. Inside the filter is a series of metal plates or discs separated by spacers. There may be several hundred of these plates. The stack of plates and spacers is connected through the center to the handle. In this exploded view, you can see two filter discs and a spacer. There are also fixed cleaner blades here between the discs. The distance between the discs determines the size of the particle that the filter can trap. Knife edge filters normally filter down to about 40 microns in size. Fluid enters through an opening in the casing, flows into the gap between the filter plates, and continues upward through the center of the discs. Any particles too large to fit between the filter plates will be trapped on the outside of the plates. Then, when the handle is turned, the discs move past the fixed cleaning blades. Particles that have collected on the discs are dislodged and drop to the bottom of the casing. The bottom of the casing must be cleaned occasionally and all dirt deposits removed. One of the obvious advantages of knife edge filters is that they can be cleaned while the system is in operation, while fluid is flowing through them. Now, this makes them ideal for systems which are in constant operation and should not be shut down. They're often found in low-flow, medium to low temperature systems, and they may filter oil, air, or water. Backwash filters are another type of special filter. While there are many different backwash filter designs, they all work on the same principle. Flow through the filter element can be reversed, causing the trapped particles to be dislodged and flushed from the filter. Such filters are frequently found in water treatment systems. This drawing is of a backwash filter with just two metal filter elements, but most backwash filters will have more than two elements. Some may have as many as 20 or more elements. And the filters are typically quite large, up to 10 or 15 feet in diameter. During the filtering process, water enters here, it flows into the hollow core of the filter elements, and passes through the wire windings that make up the filter screen. Particles too large to pass through the windings are trapped on the inside surface of the screen. The filtered water is then discharged here. Now, in most cases, there will be a separate inlet and outlet for backwashing. When the dP across the filter reaches a certain predetermined value, the inlet and outlet ports for the filtering process are closed. The backwash lines are opened, and the water is sent backwards through the filter. This backwash flow dislodges and flushes out particles that are trapped on the inside of the filter screen. A backwash filter with just a few elements, like this one, would require the system to be shut down for backwashing. If the backwash filter has quite a few elements, though, it may be designed so that one element at a time can be backwashed while the filter remains in operation. And the same is true of a second type of backwash filter that uses sand or similar material as a filtering medium. Normal flow is in this direction. As particles become trapped in the sand, the dP increases. The filter is then cleaned by reversing the flow and flushing out the contaminants. And there are screens located here and here that keep the sand itself from being flushed out of the filter. These screens should be inspected for holes periodically.